Now let us understand the characteristics of reciprocal function. The function which we are considering is a parent reciprocal function, which is f of x equals to 1 over x. Now in this kind of a function, we know that x cannot be 0 since 1 over 0 is not defined. So we can write here that x is not equal to 0. That means x is equal to 0 is not in the domain of the function. Well, all other points are in the domain of this function. Now, we'll look into the key points and then draw the graph and then consider domain range for the function. Well, some of you who know about it can pause the video, write down all the characteristics and then watch the video. Now to consider the key points, I would like to take these points. We'll start with 0, which we say for 0 it is not permitted since 1 over 0 is not a defined value. So if x is equal to 0, then f of x does not exist. So I'm writing D and E for that. So we'll take up some x values and then figure out what is f of x for those x values. F of x is 1 over x. Now if I take a value which is 1, for example, now 1 over 1 is the same number 1, right? So let me write for 1, I'm going to get 1 as f of x. If I take a value more than 1, for example, if I take it 2, then f of x will be 1 over 2, which is half, less, right? If I take a higher value, let us say 10, in that case, it will remain positive. 1 over 10 will be f of x. That means 0.1. So what we note here is that at x equals to 1, f of x is 1. That means if x is 1, then f of x is 1. But if x is 2, then f of x is half, kind of here. If x is a bit larger, for example in this case 10, it is 1 over 10. That means as the x value increases, f of x will decrease, right? For 3 it will be 1 over 3, for 4 it will be 1 over 4. So it becomes closer and closer to x-axis, but it never becomes 0, right? So if x is very large value, in that case it approaches x-axis. That means f of x equals to 0. So what we see here is that as x value increases, f of x decreases and it becomes closer and closer to 0, but it is never 0. So we can make this graph kind of like this, and I'm just drawing an arrow here indicating that we are approaching 0 from the positive side, but we are always in quadrant 1 in this particular case. Now let us consider a few values between 0 and 1. Between 0 and 1, if I take half, for example, right? So if I write half here, then reciprocal of half is 2 over 1, which is 2, right? If I write 1 over 4, in that case the reciprocal will be 4. As you can see, if I write 1 over 10, then be 10. So it becomes higher and higher. So for the values which are less than 1, for example half, in that case the y value or f of x will be 2. If I take 1 over 3, then it'll be 3, right? 1 over 4 will be 4. So it kind of increases as the x value decreases from 1 to 0. Okay? So the graph actually approaches infinitely large value as you approach 0, right? So we get this part of the graph which I can draw kind of like this, join the two. So that is the positive half of the curve when we consider the values of x from 0 towards positive infinity. Now if we consider values which is negative of these, then what do we get? So if I write negative 1, then reciprocal of negative 1 is negative 1, right? And the point corresponding to that will be negative 1, negative 1. If I write negative 2, then the reciprocal will be negative half. So reciprocal of negative number is negative and that of positive number is positive, right? So negative 2 will be how? Kind of like this. If I say a negative large value, let me write minus infinity here in this case. That means it is approaching 0, but it is not 0. It's kind of approaching 0, but is approaching from the negative side. So it's kind of approaching 0, right? So we can join these points and draw a graph. Just as it was approaching 0 for positive large values, it approaches 0 for negative large values also, but it remains in quadrant 3, correct? Now if I consider values which are between minus 1 and 0, for example, if I take a value which is, let us say, minus half, right? In that case, let's say minus half. The reciprocal will be 2, negative 2, right? Reciprocal of a negative number is always negative. Reciprocal of positive is always positive. That is one thing which you have seen here, right? Second, you will see that for negative numbers, the values kind of match. So it has odd symmetry, right? So we'll just fill in those things here. But these things we observe as we make our graph. So for minus half, which is here, we get a value of 2, right? If I say minus 1 over 3, I'll get 3. Minus 1 over 4, I get 4. And as we approach 0, let us say minus 1 over 10, then be 10, right? So it's kind of approaching a large value as we take up x values between minus 1 and 0, right? So that is how the graph really looks like. So I'll recommend the key points which we should consider are, you can take minus infinity, that means infinitely large value, plus and minus 2, plus minus 1, plus minus half, and 0. These are good points to take, okay? Now so with that you get a graph which is in quadrant 3 and in quadrant 1, correct? So that is your graph. Now what is the domain and range of this function? What we have observed here is that x cannot have 0 value, but x can have any other value, right? So the domain is x belongs to real numbers, so that x is not equal to 0. So except for 0, it can have all the values. As far as the range is concerned, it is approaching 0, but it is never 0. So the y values could be from minus infinity to plus infinity. So we can say y belongs to all real numbers, but y cannot be equal to 0. So that is the restriction on range. Quadrants, you can see it is in quadrant 3 and in quadrant 1, right? It moves from quadrant 3 to 1. Symmetry. Since we have a point, as you can see here, these points are symmetric about x origin. Do you see that? So for every point we have a point of symmetry. Do you see that? So now we have odd symmetry, since f of minus x is equals to minus of fx. What I'm trying to say here is f of minus 2 is minus half, which is minus of half. Do you see that? Minus of f of 2. Do you see that? So that is what we mean by saying odd symmetry, right? So if I replace x with minus x, what do I get? Let me show you this part here. When I say f of minus x, it means what? F of minus x means f of x is 1 over x. F of minus x means replace x with minus x. I'll get 1 over minus x, which is minus of 1 over x. And 1 of f over x is fx. So we can write this as minus of f of x, right? So in general, f of minus x equals to minus of f of x. Therefore, it has odd symmetry. So that is algebraic proof of odd symmetry, right? So I'd like you to make a note of this so that you can prove it algebraically also if required. Now when we are understanding properties of reciprocal function, we come across these two important things, which are horizontal asymptote and vertical asymptote. What do they really mean? Horizontal asymptote really means that if x is approaching negative or positive infinity, what happens to y value? Does it approach a value? So what we say is if x approaches, let us say, negative infinity, what happens to f of x or y value? So we say f of x approaches some value or not. If f of x approaches a value, in this case it does approach 0, right? We say there is a horizontal asymptote, since the value approaches but it is not really equal to, right? We also see that if x approaches positive infinity, f of x actually approaches 0, right? This time from positive side, earlier from negative side, correct? But in any case, it approaches 0, and therefore we say it does have a horizontal asymptote, and the equation of horizontal asymptote is y equals to 0. So that is the equation of horizontal asymptote. So horizontal asymptote is a line which the function approaches as x value approaches positive or negative infinity. Make a note, we could have more than one horizontal asymptote, right? Sometimes functions may approach a different y value as x approaches negative infinity or positive infinity, correct? Well, I hope you understand horizontal asymptote. Now let's look into vertical asymptote. What is that? Now vertical asymptote is again a point which a function approaches. Rather, I should say a line which a function approaches. Now, if x approaches a value, in this case 0, we know x cannot be 0, but x can approach 0. So if x approaches 0, what happens to y? So we say y approaches, or the f of x approaches, if it approaches 0, it approaches plus infinity if you are approaching from positive side. You see that? But if you approach from negative side, that means from this side, then it approaches negative infinity. F of x approaches negative infinity. So in that case, if the function approaches infinitely large value, as you approach some x value, let us say a, in this case it is 0, in that case we say there is a vertical asymptote, and this line which it is trying to approach, let me draw it with a dotted line, is called a vertical asymptote. And the equation of this line is x equals to 0, right? So we're trying to approach x value of 0, right? We're never there. As we approach x equals to 0, the function approaches negative or positively large value. Therefore, we say it has a vertical asymptote, and the equation is x equals to 0, the value of x which we are trying to approach. So these are two very important characteristics of a reciprocal function, right? Now let's look into increasing and decreasing intervals. Now, as you can see, if you move from left to right, the function is decreasing in quadrant 3. That means decreasing interval is from minus infinity to 0. And as we improve, as we go from 0 to positive infinity, we see it is also decreasing, right? It's decreasing further, right? So it starts from positive large value and decreases to 0. So that is also decreasing. So we can write union and from 0 to infinity. Therefore, in the entire domain of the function decreases. Of course, 0 is not in the domain of the function, right? So from negative infinity to 0 and from 0 to infinity, it decreases, but never increases, right? So it doesn't ever increase. Now let's look into end behavior, which you know is what happens to the value of function as x approaches negative infinity and as x approaches positive infinity, right? If x approaches negative infinity, we know f of x or y approaches 0, right? But from negative side. So I'm writing negative here, indicating from the negative side. It's in quadrant 3. If x approaches positive infinity, then y approaches 0, but from positive side. It's in quadrant 1. So that is how we can describe the end behavior of a reciprocal function. How about rate of change? Rate of change you can get by sketching slope at any point, right? So if you draw a slope here, tangent, if you draw a tangent at the point here, it's kind of horizontal, right? So as you move, you see it becomes negative. So it kind of becomes from 0 to more and more negative. Therefore, we say rate of change is decreasing, right? So in first quadrant we see it changes from 0 to negative, so it decreases, right? How about when we are considering from 0 to infinity? Here it is positive value, here it is kind of lesser positive, right? So it's very large positive value, less positive value, right? And then becomes almost 0. That means it decreases there also, right? So rate of change is decreasing from the interval minus infinity to 0, and then again from 0 to infinity, right? So all throughout in its domain, what we notice is that the rate of change of the function decreases. So that's kind of important to understand, right? Now from here, you can write down your 5 typical characteristics which makes it easier for us to identify whether it is a reciprocal function or not. So what are those? As you can see, it has a restricted domain that is not equal to 0. That's one of the important characteristics. Then it has vertical and horizontal asymptotes, right? And rate of change is always decreasing. So these are a few characteristic points which you can use by comparing when you compare other functions. Other good points are its critical values. These two coordinate points, 1, 1 and minus 1 and 1. These are very important points which you should be considering. So when we draw a graph, then we also have points like 1, 1 and minus 1, minus 1. These are kind of important key points for the function. It goes through 1, 1 and minus 1, minus 1. These points are similar to the points which you'll have function of linear function. For example, if I say f of x equals to x, the similarity is that both have 1, 1 and minus 1, minus 1 on their curve, right? So that is a similarity between a reciprocal and a linear function, right? So I hope with this you kind of get all your parent functions, right? I'd like you to go through this video once again and answer the questions given in the description. Thank you and all the best.